So we're about to start the second talk of the session. This will be Paul Ganssle, and he will tell us what to do when the bug is in someone else's code. The stage is yours.
All right. Thanks, everyone. It's really great to be back at PyCon. As Jonas said, my name is Paul Ganssle. I'm a software engineer at Google and also a contributor to many open source projects. Among other things, I'm a core developer of Python, where I've worked on datetime and zone info, and I've maintained libraries like dateutil and setup tools and gotten involved in a lot of packaging things. I don't recommend that last part. I mean, go to the packaging summit. It's going to be really fun. As someone who primarily develops libraries, I'm obviously a fan of shared code, but I recognize that there are risks to taking on dependencies, whether that's a third-party dependency or just like an internal dependency on some other team in your organization. And one of those risks is the topic of today's talk, which is when something you depend on has a bug or other incompatibility, it's not as easy to fix as it would be if it was a bug in your own code. But first, I'm going to start with a warning. This talk deals with a number of strategies for handling bugs in your dependencies, but it's organized as a series of strategic retreats away from the right thing to do, right? So we're going to start out with the right tool to hammer in this nail, and then we're going to go to more sort of hacky and even dangerous things as we move along. So what do we mean by a bug in someone else's code, right? So here's an example that I encountered at work. This is just a minimal reproducer. So the way this function is supposed to work is that you have data frame. It takes ag, and it's supposed to pass this function f. Ag itself takes two parameters. It takes the function, and then it takes the axis. And then it's supposed to pass all the additional positional and keyword arguments to the function that you passed, right? So what this is supposed to do is it's supposed to apply f to every row, and it's just going to pass to f the row and then the number 3. In Pandas 1.1.3, which was the most recent version when I first wrote this talk, this actually raised an error. Some kind of weird thing about the axis parameter was being passed twice. So that's kind of strange. So we can check the documentation, make sure that I understood how to use the function correctly. And you can see, yes, Pandas did indeed intend for you to use it this way, but it doesn't work. So this is a bug in Pandas, or it's a bug in their documentation, one or the other. So what should I do about this? The right thing to do is to tell Pandas about it, because how are they going to fix it unless they know about it? And if you're feeling adventurous, you can submit a patch and fix it upstream. In this case, it was fairly easy to do, and crucially, it was fairly easy to review that patch. So this was merged just a couple days after I made the pull request, and then it was scheduled for release in 1.1.4. So all I had to do is wait for the release to come out. And just as an aside, this all seems very standard for me because I do a million open source things. But I can understand if it's sort of intimidating to think oh, I'm going to make this open source pull request and ask someone to take my patch. I don't have time to get into exactly what you should do and the practical aspects of it. But I gave a talk in 2018 at PyData about exactly this. So if you look at the slides, they're on my website and stuff. You can find that talk if you're interested in that. So far, this is all looking like a great open source success story, right? I just have to wait for the updated version and then update it in production, and we're good to go. So what can go wrong? Well, for one thing, maybe I don't want to wait until Pandas makes a release because my boss is saying, hey, on Friday we have to deploy this, and you have bugs in your code, and I can't be well, I fixed it upstream, so ask them, There's also such thing as long upstream release cycles, right? Maybe Pandas is releasing every week, but in just a couple of years ago in CPython, they shortened the release cycle from 18 months to 1 year. So the short release cycle is 1 year. You may not have a year to wait for your features to get in. And of course, I don't know how many of you get to deploy Python the day it comes out, the newest version, right? But probably there's going to be a fairly long QA process after that, 6 months to a year before you get to use the latest version of CPython. So basically, you're probably going to have to wait if you want to do this. So what do you do in the meantime? Well, probably the best thing you can do is to just sort of work around it. In this case, it's like it's fairly trivial to work around this because all I have to do is, instead of passing this by position, I can just pass it by keyword. So I could just change it to pass by keyword, maybe leave a little to-do comment or a comment saying like, this is written this way because I was working around it, and then we can be done. And this sort of thing works just fine if you hit the bug in exactly one place, and if the workaround is like fairly simple, so it's just, I just changed one little thing. It's also especially good if you're indifferent between the bug triggering code and the workaround code. Like I really don't care in this case whether it's positional or keyword, so I maybe don't even need that to do that to do comment. If some of these things don't hold, it might be good to sort of wrap your workaround into a wrapper function. So here I've sort of just taken that little workaround and I've made it a little more generic, and I've wrapped it in a function that is kind of a drop-in replacement for DataFrame's ag function. And what that does is it's just going to, it just sort of takes whatever, it takes arguments the way that we're expecting the arguments to work, and then all the positional arguments, it turns them into keyword arguments and passes them to dataframe.ag. So this is useful because it can help you encapsulate any like complicated workaround logic. It also provides an easy target for removal. So what you can do is you take all the places in your code where you're calling dataframe.ag and you replace them with dataframe_ag. And then later, when you've fixed the bug and 1.1.4 is your main thing, you go and you do a search and replace and you put back the original code, right? Okay, so we can all say that we're going to clean up this technical debt that we've just incurred, but in reality, this workaround function is going to last forever, right? Or maybe. So I have one strategy you can use to sort of make it less of a hack and to minimize the scope is what I'm calling opportunistic upgrading. And the idea here is that in our wrapper function, instead of just unconditionally applying this hack, I will just write a little function or something that says, if this pandas bug is currently active, do this. Otherwise, just return the original thing, right? So now we have this sort of thing which says we're applying our workaround if and only if the bug is present. And I would say that there are two broad strategies for determining whether or not the bug is present. One is by feature detection. So you can, in this case, it's fairly easy to trigger this bug. So I just have this minimal reproducer. I can just run it. And if I've triggered the bug, I return true. And if I didn't trigger the bug, I return false. And I actually only have to run this one time because the pandas version is not going to change. The bug is just there or it's not there. So I can just actually cache this. You can also check the version, right? Because in this case, I know that the bug is fixed in 1.1.4, and I also happen to know that the bug wasn't present in 1.1.0. So I can just check the versions, and then I'll know whether or not the bug is present. So there's pros and cons for both of these. I tend to prefer the feature detection version because it doesn't require knowledge of exactly which versions are affected. Most of the time, you don't know that you've got a released bug fix up somewhere, and you can just opportunistically upgrade when the version hits a certain number. You just sort of are like, well, if they ever fix it, this will start to work. You may not always also have accurate version information. And also, the bug might be simple to check for, like in this case, but it might be hard to describe in terms of versions and platforms. So if you really want it tightly scoped, and you're only triggering it on Debian, on 64-bit architectures with Python 3.9.7 and Pandas 1.1.4, this is a lot to try and encapsulate into your version detection, and it's quite easy to just trigger the bug. Whereas the version checking version works when the bug is kind of hard to detect. So if the bug is a memory leak, right, you're not just going to like wait until your computer runs out of memory and you're like, oh yeah, I should have used the workaround. And if it's a seg fault, that's not something you can recover from. And the other advantage of this is it's relatively simple to implement, especially if the minimal reproducer can be a little complicated. So once you've written your opportunistic upgrading function, you can either incorporate it into the wrapper function, or you can actually conditionally define the wrapper function based on whether the bug is triggered, right? So if it's cheap enough to call hasPandas bug, at import time, you can say, define this wrapper function if the bug is present. Otherwise, define the wrapper function to be the original function that I'm replacing. And then you're good to go. And this really minimizes the scope because you're not even defining an unusual function. So for each of these strategies, I'm going to give a couple real-life examples where they're applied. Probably the most prominent thing that you would see these in is something like feature backports. So import lib resources is only in Python. It started in Python 3.9. Almost everything in the backports namespace. These are basically wrapper functions or workarounds, right? Because you want new features from something that exists in a future version, and you can use these backports to sort of simulate. And most of the time, these do use opportunistic upgrading, right? It's a very common idiom to say like try import lib.resources, except import error, import lib underscore resources. 6, the package many of you are probably familiar with, was used extensively to make Python 2 and 3 compatible. That used essentially the same strategy. And when I first wrote this talk, it was number 2 on the most downloaded PyPI packages. Interestingly, in the 2 years since then, it has now dropped to 9. So maybe my little joke about we're never going to remove our to-do comments is not quite accurate. So thank you all for stopping using Python 2. The last example is just kind of a pitch, so I'm not going to talk about it. But check out the slides, and you can check out PyTZ deprecation shim if you want to know more about that. All right, so let's get into the next strategy. And this is where we start getting into properly like dangerous and hacky territory, and that's monkey patching. So the way monkey patching works is that so Python, most modules and classes in Python are mutable, and they live in a global namespace. So you can actually just dynamically modify the code that you want to patch at runtime. So here's an example where we decide that the abs function is like a bit stodgy. You know, it's always returning positive numbers. And so we want to be like, let's be a little bit more chaotic, okay? So 20% of the time, we're going to return a negative number. So what we can do is we define that function, and then because we want everyone to use our abs, we take dunder built-in.abs, and we replace it with our function, which we've called sixpack because it's an upgraded abs. And you can see when I print the return value for abs, like about 20% of the time, it's a negative number. And this affects not just that local namespace, it affects everyone using the namespace. So evidently, the fraction object uses abs somewhere in its hash calculation. And so if I just generate 100 copies of one fraction object and I hash them, I'll get 2 different values. So how does this help us, right? It's super cool that we can break the hash function of fraction objects, but that's not exactly fixing a bug. So let's jump back to our pandas example, right? So instead of implementing our workaround as a wrapper, we could implement it like this, where we use our opportunistic upgrading strategy, very critical when monkey patching, and we can, instead of trying to replace all the call sites with dataframe underscore ag, we can just replace the ag method on dataframe with our wrapper function. So what this will do is it'll like globally and transparently fix the issue for everyone in the namespace, which is kind of important, which is kind of useful when someone else is calling ag and you're calling that person. So if they have some 200-line function and they have one place where they're using ag wrong, you can't really patch their just a single line in their function. You definitely can't monkey patch it, and you don't have any control over it. It's just another one of these someone else's bug problems, right? So what you can do is you can patch the ag function when you're calling before you call their function, and then their function will be fixed. So now we're going to move on to why this is a terrible idea. Most of these strategies at this point are kind of terrible ideas, so there's going to be large sections like this. So one problem is this is sort of action at a distance. Well, you're sort of dynamically modifying. I mean, it should be obvious, right? Like you're dynamically modifying code. No one is really expecting you to do this, right? And because they're not expecting you to do this, they're not going to code with your workaround in mind. They're not going to be trying to keep compatible with it. It's obviously going to break if they start making changes that you're to implementation details that you're relying on. And in fact, you're usually tightly coupled to implementation details when you're using monkey patching. One example of how you tend to be tightly coupled to implementation details is that it's very important to scope your patch correctly. So here's an example where we've got two almost identical versions of the same module, and they just tell you what pi over 2 is. And we've decided that 3.14159, whatever, has too many digits. We're just going to call pi 3. And so we're going to patch math.pi to be 3. And critically, we've done that after we've imported the pi module and pi module 2. So the first version of the pi module returns 1.5. So the patch is taking effect. The second one, it's clear that the patch didn't take effect. And the reason for that is that in the first module, every single time you call this function, it looks up the pi attribute on math, resolves that to a number, and then returns that. In the second version, at import time, it looks up what pi is on math, stores that as a variable, and then every time you call the function, it calls whatever it stored, right? So if you want to patch pi module 2, you actually have to patch it in the pi module 2 namespace. So it's not actually quite as global as you would hope. You have to patch it, if people are doing this kind of importing, you have to patch it on the module that you want to change. So after all this reasoning, like you decide, all right, it's kind of a terrible idea, but I still want to use it. I would highly recommend that you scope it as tightly as possible. If you really only need to apply the patch for a short period of time, or just during one function or one section of a function, you can use a context manager to do this, right? So you can imagine we'll have a function that patches the code and then another function that restores the patch. And you can just write a little function like this using context_lib.contextManager, and you can use it as a context manager to say, all right, I'm calling someone else's function. I want them to have the patched version of it, and then I'm going to restore the original one so I don't create too much chaos everywhere. And you can use that either as a context manager or as a decorator, right? You say, during this affected function, I want the patch applied, but at no other time. So let's move on to real-life examples. A lot of the rest of the examples come from packaging, and I don't know if that's just familiarity or because they like to do this kind of stuff, or both, but it may be a little disturbing for people who think that it's all rock solid up there. So setup tools, this is really a cautionary tale as an example. It's not like 6, where 6 was a godsend. Setup tools extensively patches distutil, and it does it on import. So when you import setup tools, it actually like fixes a bunch of bugs in distutils, and I guess at the time, this was useful and good, and it was fixing things in people's code that you didn't control when you were trying to build their packages. And so pip started to like this, and so that when they were running your setup.py, they would invoke the monkey patch even if you didn't import setup tools. So then people started to depend on distutils features that were actually setup tools features, even though they never thought they were depending on setup tools. It became a huge morass. So this was expedient at the time, but setup tools has taken like years to unravel this, and it's still not totally unraveled. Like it's caused lots of problems. So this is one real life example. I mean, I guess I could have just told you like mock.patch works with monkey patching, and that's something that people kind of like, but I don't know, this one's more fun. Okay, so now we'll move on to the next strategy, which is vendoring. So Webster's dictionary defines vendoring as the word you have entered isn't in the dictionary. But really, that's just because the fat cats at the dictionary don't want you to know about this strategy. But I'm here to tell you the truth. So vendoring is when you include a copy of one or more of your dependencies in the project's source code. I don't know why that was so secret. So the way this works is you just sort of take the source code of the dependency you have, and you copy it into your project tree somewhere. And then say the thing you're trying to vendor is called squalene. You would take all the references to squalene and you would change them to be myproject._vendored.squalene. And if you need to apply some patches to this vendored copy, you would apply them to your local copy. So the advantage here is that there's no chance that your hack will break if the dependency is upgraded. It has a lot of the same problems as monkey patching, except that here you're not modifying the global namespace. So it's just scoped to your package, and you don't have to worry about the dependency breaking your patches because you control when the dependency gets upgraded. This is also useful because it allows two packages to use otherwise incompatible versions of a shared dependency. So like if your library depends on library A and then library B also depends on library A, but B needs version 2 and you need version 1, you can vendor version 1 and let B use the global version of it. So the cautions here are, for one thing, if you have these two versions coexisting, things may get a little weird, right? So if you can imagine, squalene has this object called magnitude, and magnitude implements comparison. If you're comparing between two versions from the global package, things will work great. If you're comparing two versions from the vendored version, it looks great. But if you mix and match, all of a sudden they're like, well, what is this vendored magnitude thing? I don't know anything about that. No, type error. This isn't going to happen. And this is actually compounded by the fact that references to the package's top-level name within the vendored package will still hit the global package, but then also relative imports will hit the vendored package. So if squalene is doing some mix, they're going to have some mix of functions from the global package and from the vendored package. And to solve this, you need to do something like either patch the whole source code to remove all references to the top-level package, or you do something with import hooks, or you mess around with the path. None of these things sound like a fun, leisurely activity for your weekend. So the downsides here, it's kind of hard to implement, correctly at least. It's hard to maintain, and it has a tendency to be like leaky in one way or the other. We saw one example, but there's like a million, because the import system was not really built with vendoring in mind. And this also doesn't work well for any dependency that's part of the public API, right? If you're returning data frames, you can't be returning data frames that were defined in your weird vendored version of pandas that has a fixed ag function, right? You have to be returning them from the global namespace. So this only works for things internally that are using the vendored API. So this tends to be more useful in like applications. Real life examples. Oh, look, pip and setup tools are back on the list. So pip and setup tools vendor all their dependencies. And this is actually one of the weird ones where it kind of makes sense, right? Because they're at the base of the dependency tree. So they do it to avoid bootstrapping issues. They don't do any patching. And they kind of get it to work by manipulating the namespace resolution. They do it in like incompatible ways, so it's not great, but it seems to work. There's an application called Invoke that vendors all its dependencies. And this is a cautionary tale, because you can see even though they've been updated kind of recently, the Invoke has, none of the dependencies have been upgraded in over 5 years. And I think some of them have CVEs on them, so it's not great. And in a little bit of irony, this talk itself is an example of it. So reveal.js and Gecko reveal.js, I vendor them into the source, so it's going to be easier to reproduce this talk in 5 years when I've totally forgotten about it. And Gecko reveal even carries a patch, because when I was first putting this talk together, I found a bug in Gecko reveal, and I tried to upstream it, but there wasn't enough time, so I just modified my local copy of it. And now it's almost 2 years later, and nothing's been merged. I'm not sure if this package is still active or anything, but now I'm just kind of maintaining a fork of reveal, a Gecko reveal inside of my talk repo. Which brings us to the last option, maintaining a fork. So the last option is basically when you are deploying and maintaining a patched version of the library or the dependency in your production distribution, right? So the difference between vendoring is that this is global. Rather than using an unmodified version of Upstream, you would just take the patched version of your of the thing and put it in your production pipeline, whether that's your Linux distribution or a mono repo or your own mirror of PyPI where you're serving up patched wheels. Unfortunately, in my experience, people will take this as their first option because kind of like just patching your local version before deployment is relatively easy, and the cost for this really comes later on down the road. So if you do want to do this, it tends to be done, mostly the way I've seen it done is you take the original code and you store a tarball of that, and then you store a series of patches that are going to be applied to it before it gets built. Most people I've seen use Quilt for this, and I don't have really time to go into like how to use Quilt, but I found this blog post which does a much better job of explaining how to use Quilt than I would be able to in the 30 seconds that I have. If this is too complicated, for very simple cases, you can also just sort of like use like sed or other little search and replace at build time. For simple patches like the path here is in this thing to deploy is wrong, and I just want to globally replace it. This idiom seems fairly common from what I've seen in the Arch Linux distribution, where they have a fairly strong cultural norm against carrying patches on their on the things they distribute. So when they do carry patches, they tend to be very simple things that can be executed just with sed. So back to the downsides, because I really don't like this strategy. The downside is that you're maintaining a fork that your upstream doesn't know about, right? So when they don't know about it, there's a good chance that they're going to make decisions that are incompatible with the things that you're patching, right? And then every time they make a change, this is going to add a bunch of friction to your upgrade process, because you go to upgrade and then your patches don't cleanly apply, or you have to rewrite large sections of the patches because your approach was different than their approach. And they're certainly not making any guarantees of compatibility. If you file a bug that's like, my patch doesn't apply right, they'll be like, why are you carrying a patch? Why didn't you submit that upstream? And the worst case scenario here is that the other people in your organization who are using this start to depend on your version or specific details of it, and then you can't pull back your patches, and now you have just a whole ecosystem that's built on this alternate fork, and you're increasingly unable to pull from upstream. So I hardly have to mention any real-life examples. Like every Linux distro does this. It's incredibly common in industry. It's almost a default in some ways. But I'm going to take this time to mention a success story, which is when I first got to Google, I took on the task of helping to keep adders up to date, but we had a whole bunch of patches that we were carrying on adders, just little things. And one by one, I was able to remove all of them except for one, which was that adders relied on Zope for their tests because they wanted to make sure that Zope worked with adders, which is great, but we don't use Zope anywhere, and I didn't really want to package and deploy Zope just for the purpose of running the adders test, which had no effect. So that was our one patch. And so I actually made a pull request. I thought it was a long shot to say, we'll make Zope an optional dependency. And amazingly, Hinnock accepted it, and I got the last patch off, and it's like a breeze to upgrade adders now. So let's go to a recap of the strategies that we covered. So patching upstream, that's the gold standard, right? You fix the bug for everyone. There's nothing for you to maintain. I mean, there might be for the maintainer, but hopefully this would actually improve your relationship with the maintainers because they're seeing that you're willing to fix bugs for them. The downsides here is delays, right? You have to, and also you have to convince someone to accept your patch. I've shown some success stories. I've also shown at least one failure story, right? Gecko Reveal did not accept my patch. If you can't patch upstream or in the meantime while you're waiting for your patch to deploy, wrapper functions I think are a perfectly acceptable way to do workarounds, right? They help maintain compatibility, they're easy to remove, and then you can deploy them immediately. The downside is you can't always apply this strategy, right? There are just times when you need something else. So when we move into the more dangerous strategies, there's monkey patching, which allows you to make more targeted global fixes, and it doesn't have any problems. It doesn't introduce the same packaging and deployment problems that the other strategies do, but it can be hard to reason about and can cause all the issues that I mentioned. There's vendoring, which can unblock your dependency resolution issues and isolate your changes from the wider system, but it's it has a lot of the same problems as monkey patching. And then there's maintaining a fork, which I did put a pro column on this, even though I didn't like it. It is relatively easy to implement, and there are a lot of tools that exist for this. So that is the end of my talk. I'm going to leave you with a couple of final thoughts. The first one is that I really think that patience is an underrated virtue here. Each of these strategies involves incurring some technical debt, and some of them involve imposing technical debt on your entire organization. So you should consider developing organizational strategies that would allow you to patiently wait for upstream for upstream fixes to be deployed. And some of those strategies could be strategies for making it faster, right? So developing good relationships with the maintainers of your dependencies so that you can get your patches in. And the last thought I'll give you is that it's very tempting to say, well, we're in for a penny, in for a pound, right? We're already patching this Zope thing, and that's not going away. So we may as well patch a whole bunch of other things as well. But you should consider that each one of these hacks represents technical debt. You should accrue it thoughtfully and not too much of it. You should pay it down as quickly as possible. So with that, I will leave you with those thoughts. I'm going to run to another talk right after this, but I'll be around the conference for all the way until the end of sprints. So find me anytime. I'd be happy to talk about this or date times or anything else you'd like.